Hello and welcome to week 3 of C++ programming. We're going to start this week off with a little adaptation to one of the problems in the book. If you've got the 8th edition of the Savage text, you'll notice number 16 in chapter 3 asks you to write a program converting Fahrenheit to Celsius. They're actually asking you to find a temperature that's the same in both of them. What I want us to do for our guided practice, I want us to create a menu-driven program that will either convert Fahrenheit to Celsius, Celsius to Fahrenheit, and then we're going to throw in miles per hour to meters per second for our engineering students. So this program is going to have a menu with 4 options, 3 of them being the conversions that I just mentioned, and then the 4th will be an exit. And in this problem we will revisit the do-while loop that we looked at the end of last week, and then we're going to take a look at something new for this week in chapter 3, and that is the multi-branch decision structure. Now we actually haven't coded an if-else statement yet, which is the single or dual branch decision structure. We're going to be doing that in the next assignment this week. The multi-branch decision structure you will find in your text starting on page 121 in the 8th edition of the Savage text. And I still do not have a copy of the 9th edition. I'm getting that tomorrow. So I will come back and update this video and put on the screen right now the page number for the 9th edition, if it is at all different. And you can see there that the multi-way decision structure is the if, else, as well as, if you turn forward a few pages, to the switch statement. So I want us to use the switch statement in this program to help us facilitate our menu-driven program. I'm going to start by opening a brand new dev project. Still a console application, and let's call this last name first initial. We'll call this Conversions Menu, and maybe chapter 3. Okay. I'm going to create a new folder for this project as well and call it the same thing. And remember what I said about keeping all of your projects always. They come in handy later on down the line. Now, some of you might be going on to the pre-engineering program or the engineering program and may not be doing programming for a degree, or for a career. However, if you keep track of your stuff, the more organized you are, the better. And there may be things that you want to look back on in the future. So I recommend being organized and keeping every project that you make. Okay. So I'm going to put my name at the top and the date. And the file name. And our description. I'll say this is a menu-driven program which will give the user the choice between, we'll say, performing a Fahrenheit to Celsius conversion. Celsius to Fahrenheit. Go ahead and hit enter. This is getting long. Or miles per hour to meters per second. Okay. In this menu-driven program, we're going to use a switch statement to determine which choice the user made. And the switch statement in C++ handles integers primarily. You can also use characters. If you notice in the program example that they do in the book where they're displaying the grades, you can use characters as well. I'm just going to use numbers, and it's going to be a numbered menu. So I'm going to create a variable. I'm going to call it int in choice. And then in our conversion process, we'll need a couple of variables. I'm going to declare those as well. They're all going to be doubles. I'm going to do degrees Fahrenheit, so degrees F, degrees Celsius, and then MPH for miles per hour. Okay, so let's start by displaying the menu. And I'm going to put an end line, and then choice 1. Convert Fahrenheit to Celsius. And remember, you can also use the ENDL command. I'll do that on this next one just to show you the difference. I believe I did that in an earlier assignment this year. Meters per second. The end line might be a little bit easier to read than the others. Our last choice is going to be the exit. We'll read in our choice. Okay, here comes our multi-branch decision structure. Keyword switch, and then in parentheses you pass in the variable choice. And in the switch statement, you're reading in the variable, and then you create cases, and it will look through each case until it finds one that matches, and it will perform that case. So case 1, and I'm going to type in all the cases first, and then we can add the values. I'm not sure why it's cascading them there. And then you can also have a default case in the event that the user types in something that it doesn't recognize, or it didn't find a match. So for case 1, we will be doing the conversion Fahrenheit to Celsius. So I'm going to have a cout statement in here. Enter a temp in Fahrenheit. Read that in. And then perform the calculation, and I'm going to do the output all in one statement. Now remember, with integer division, you lose the decimal portion. So here I have to put 5.0 divided by 9, or 9.0. That will give us that will force those to be executed as doubles and double division, and multiply that conversion by our degrees Fahrenheit minus 32. That'll give us our degrees Celsius. I'll use the end line. Okay. Now, a switch statement, once it finds a result, it needs the break statement in there. Otherwise, it will continue to perform all of the code for the next cases, and you'll see that written on page 129 in the 8th edition. It says when the computer encounters, if you omit the break statement, then after executing the code for one case, the computer will go on to execute the code for the next case. So you have to have a break statement in there, otherwise it will keep performing the rest of the stuff that are in these cases. So each one of these cases needs a break statement in it. Good idea to put it in there now. Now, if you don't put the break statement in there, you're not going to get a syntax error. So the program will compile, but it will just not perform the way you're expecting. Okay. I'm going to do number 3 for you, and I'm going to let you do 2 and 4 on your own, the Celsius to Fahrenheit conversion, as well as the exit. And for the exit, you don't have to put any code. Really, that's just already done for you there. So for case 3, enter a speed in miles per hour. And remember, our physics students would know that if we don't have a direction, then it's not a velocity. Velocity is a vector, so it has a direction. So this is a speed, unless we specify a direction. So this is enter a speed in miles per hour. Read that in. And I'm going to use the just an approximation of the conversion, and I'm going to do miles per hour times 0.447. And just to be quick, I'm not putting a statement in front and say this many miles per hour is equal to this many meters per second. So we'll already have that enter a speed, and that will still be on the screen. So making it shorter, meters per second. Okay. For the default, I'm just going to have it say that your input was incorrect. So I'll say incorrect choice. Let's compile what we have so far. Make sure it runs. What did I forget? Even the best of us will forget our using directive. Using namespace standard. We'll clear up that little error. Anytime you see that not declared, cout was not declared, or anytime you see that it's saying any of the key words are not declared, then it's not sure where to find that definition. That's what this whole using namespace standard statement is for, is to let it know which namespace to use to find these definitions. So adding that statement in should clear that up for us. Except for I forgot my semicolon. And that's another good thing about this compiler, is it'll let you know. Here it even said expected semicolon, so that and it tells you what line. Even here it told me line 23. So really it's the line previous to that is where I missed it. And that should be good. Oh, forgot a semicolon down here too. Line 38. See line 37 here. Forgot my semicolon. Okay. There's a mantra, code a little, test a lot. So you don't want to get too far into your program before you start testing. Otherwise, you're going to have a slew of errors like you saw there in mine. Okay. All right. First thing I noticed is that those periods after the 2 and 4, when I did the end line instead of using the \n instead of end line. So I'm going to fix that really quick. Okay. Maybe put a period after exit so I'm consistent here. If you wanted to, you could maybe have that main menu be set apart a little bit. I'm going to put or maybe put those at the end. Maybe throughout. And this main menu, I'm going to go ahead and move it over a little bit. Alright, now let's take a look. Oh, forgot the semicolon. Okay. Forgot the inline there as well. Let's put an inline here. Let's see how it looks now. And I wouldn't recommend doing it like I did here, where you're mixing inlines with the inline character. I'm just doing that to demonstrate that you can do both. Okay, that looks a little bit better. Now we have our menu, and we can make a choice. I'm going to choose number 1, test it out, enter a temperature in Fahrenheit. Let's pick something that we know what the temperature in Celsius is. 32 degrees Fahrenheit should be 0 degrees Celsius, and that's correct. Okay. Something I'm also not doing is prompting the user for their choice. So maybe I'll do that. I'm going to put a second inline in there and prompt the user for the choice. Let's say maybe just choice. Make it simple. When in doubt, keep it simple. And I'm going to go ahead and test the miles per hour portion. Okay, number 3, enter a speed in miles per hour, 60 miles per hour, 26.82 meters per second. Okay. Alright, the last thing I'm going to do before I let you finish case 2 on your own here is I want to put this whole thing in a loop. That way the user can continue to pick these choices until they want to exit with 4. So what I'm going to do here is I'm going to encapsulate everything except for the return 0 portion. I'm going to encapsulate all of this starting with the menu display, but leaving my variables up at the top. And I'm going to create a do while. I absolutely want this to be executed once, so I'm going to do do open bracket, and then something you can do anytime you encapsulate already written code inside of a larger bracket, maybe a do while or a switch. You can highlight everything and then hit the tab key, and it should tab it over for you. And let me put my closing brace there. Okay, so here's my do, closing brace for the do while. I'm going to have this loop continue while in choice is not equal to, and if you recall from the chapter 2 relational operators, not equal to is exclamation mark equals, because obviously the equal sign with a slash through it, like we typically use in mathematics, that character doesn't exist in your ASCII character set, so, or on your keyboard. So we're going to use that as the C++ not equal to symbol combination, and we're going to say not equal to 4, because once we type 4, that's going to break out of this switch statement, not executing anything, and then that will exit our program. Okay. So run it now. We're missing the semicolon at the end of the while loop. So remember, the do while loop ends in a semicolon. Okay. I'm going to perform number 1 again. Temperature in Fahrenheit, let's do 212, which is the boiling point. It should be 100 degrees Celsius. Okay, now what you see it does is it just spits the menu back out, and the user can continue until they type 4, and that should exit the program. One thing I am going to add, if they do choose 4, I would like to see an inline in there. That way the new menu isn't smashed up against your previous line. So I'm just going to do inline, maybe a couple inlines. Okay, so we should see here, how about a nice temperature 78, 25 degrees Celsius. Oh, now the choice I made, putting the inline in the 4, that will only happen, or only gets executed when we exit. So really, that's not where I wanted it. I'm going to take that and pull that out and just drag it down here. And now it should do what I want. I just wanted inlines every time it loops back through. And try it again. Let's do a nice hot summer day. Okay, now I get the space that I'm looking for. And that should do it. As you saw with my programming today, a lot of trial and error. You don't have to construct all of this in your head and spit it out perfectly. Clearly, I don't. So it is a trial and error thing. That's what the debugging is all about. Running it and seeing how it looks, making changes to the layout when you want it, and then correcting any errors that you might have. Okay, so what I want you to do is finish in, case 2 on your own. It'll be similar to this, only use the conversion for degrees Celsius converting to Fahrenheit. If you don't know it, it's just you have to deconstruct this. It'd be 9/5 times the degrees Celsius, and then at the end you add 32. And you can Google that as well, and it'll give you that conversion. So this is the first of the assignment of this week, a mini assignment for you just to finish that. And then later this week we will do the Archimedes Principle program together, and then you'll do one from Chapter 3 on your own. Happy programming, and this is J Money reminding you to know yourself.